Audio Jungle. Audio Jungle.
Hello everyone, myself Naren Singh Maurya. So guys, today we'll solve GATE 2015 rocket propulsion problem, right? And here the problem is a rocket engine produces total impulse 112 kilonewton second in a burn time period of 3.5 minutes with a propellant mass flow rate 0.25 kg per second. The effective exhaust velocity of gas ejecting from the engine is okay. Now, so we'll write given data first. Okay. So total impulse they have given. Total impulse it is denoted by I T is equal to how much? 112. Okay, 112 kilonewton second. All right. Burn time means TB. Burn time of the propellant they have given 3.5 minutes. So I can convert into second. 3.5 into 60. Wait, I will calculate this. So 3.5 into 60. 210 second. 210 second with a propellant mass flow rate of, so m dot p they have given how much? 0.25 kg per second. They are asking calculate effective exhaust velocity. Okay, that we need to calculate. All right. Now, so V effective they are asking. Okay. Now, for this rocket, what is the total impulse? That is IT. This IT we have 0 to TB, okay, into F dt, where F is the thrust. What is the TB? TB is the burning time for the propellant. Where is the propellant? See, this is what? This is propellant. All right. This is what? Propellant MP. So, and F is the thrust. All right. So now if you integrate for the given time period, okay. So what will be the IT? IT will be F into TB. Yes or no? The total impulse they have given, so we can calculate F. F is nothing but IT divided by total burning time. What is the IT they have given? IT means total impulse. It is 112 kilonewton second. So 10 to the power 3. What is the TB burning time? In second, it is 210. So if you will calculate this, it is nothing but 112 10 to the power 3. Okay, divide by 210. So thrust is 533.33 Newton. Now, what is the thrust? Thrust is nothing but mass flow rate, okay, of the propellant, all right, into V effective. So, in this case, we need to calculate V effective. It is nothing but thrust divided by m dot p. What is the thrust? 533.33. What is the m dot p? 0.25 kg per second. Okay. So we can calculate P effective divide by 0.25. It is 2133 meter per second. This is the answer. Okay. So meter per second, it is 2133.33. This is the answer. Hope you understood this. This is simply a formula based problem. All right. Now, next problem. Here in this problem, a rocket nozzle is designed to produce maximum thrust at an altitude h is equal to 8 kilometer. Okay, this is what sea level. Now, okay, so just say 8 kilometer. All right, from the sea level, the nozzle operates in under expanded condition for h greater than 8 kilometer, under expanded condition for h greater less than 8 kilometer, sonic exit condition for h greater than 8 kilometer, unchoked condition for h less than 8 kilometer. Now for this rocket, they are talking about the maximum thrust. So what is the maximum? See, like this rocket is what flying. So definitely whatever the exit pressure, it will be PE, and what is the atmospheric pressure or ambient pressure, it is PA. And at the same time, what is the exit velocity, it is VE. Okay. If I say here we have a propellant burning. Okay. Here this is what propellant. This is the propellant. So propellant is what burning. So mass flow rate of the propellant m dot. If I say what is the formula for the thrust? So thrust is nothing but m dot. We are denoting thrust here by F. So better we'll take one notation only. F is equal to m dot P into VE plus AE. What is AE? AE is the exit area. Okay. AE PE minus PA. This is the formula. All right. Now, if I want to find the maximum thrust. So this F will be F max when this component is what max and this component is what max. All right. First component and second component. First component value depends on the mass flow rate as well as exit velocity. Okay. More exit velocity, more thrust. More mass flow rate of the propellant, more thrust. What about second? Second is related to the pressure. Second is related to the pressure because exit area is constant, PE minus PA. I will write in next page. If I want to say this is maximum thrust, okay, so m dot p, it is maximum, that is true. I mean, it should be maximum. What about the second? Because as per given option, we need to relate with the second. Why I am saying this? Because if altitude is changing, okay, so definitely the exit velocity will not depend on exit velocity will not depend on altitude. It is 8 kilometer or more than 8 kilometer or less than 8 kilometer, doesn't matter for exit velocity. It depends on the chamber pressure, depend on the chamber temperature. Similarly, mass flow rate of the propellant also, it is not depending on the altitude. But second term, pressure, you can check pressure is what depending on the altitude. All right. Now, if altitude increasing, okay, we'll go for the second. So this should be maximum. This should be maximum. P minus PA maximum leads to F max. But when P minus PA will be maximum, when this PA is what? Minimum. And when this PE is what? Maximum. Again, exit pressure depends on the chamber pressure. Yes or no? Exit pressure depends on. But what about PA? PA depends on the altitude because it's a ambient. So ambient pressure depends on the altitude. Okay, if altitudes increasing, PA will be decreasing, right? That is the one thing. Second thing, in this way also you can understand. So what should be the H should be the greater than 8 kilometer. That is the one thing. Check. We have H greater than 8 kilometer. That is the answer. Now here also we have a H greater than 8 kilometer. So, but they have given sonic exit condition and this is under expanded condition. So again we'll check under expanded condition. What is the under expanded condition? What is the mean of the sonic exit? Sonic exit is what is the choking condition. Choked means Mach 1. Okay. So we'll check it is under expanded condition, it's greater than 8 kilometer or not. If it is under expanded conditions, then option A will be correct. What is the under expansion and over expansion? Under expansion means always PE greater than PA. Over expansion means PE less than PA. Check, this value will be maximum when PE greater than PA. So PE greater than PA will also be called as a under expansion. This is also called under expansion. Okay, if PE greater than PA, and obviously if you are going upward direction. So PA is what decreasing. It means directly PE greater than PA you will get always. And if this condition is satisfying, then it is called as under expansion. All right. So option is your answer. Many way to understand. This is the one explanation I have given to you. All right. Now, this is the next problem, 40. Question number 40. Get 2015. See, a solid rocket motor is designed with a cylindrical end burning propellant grain of length 1 meter and diameter 32 centimeter. Okay. Density of propellant grain is 1750 kg per meter cube. The specific impulse of the motor is 190 second and the acceleration due to gravity is 9.8 meter per second square. If the propellant burns for the period of 150 second, then the thrust in Newton produced by the rocket motor is. So basically we need to calculate thrust here. With the given data, what they have given? They have given length of the propellant LP. It is 1 meter. Okay. Diameter of propellant they have given 32 centimeter. Density of the propellant they have given how much? 1750 kg per meter cube. The specific impulse for the rocket they have given 190 second. G they have given 9.8 meter per second square. And propellant burning time means TB they have given how much? 150 second. They are saying what is the thrust. We need to calculate. All right. Now check. So okay, this is the rocket. Now inside this we have packed propellant here. Okay. This is the propellant. All right. Now for the propellant, we can do one thing. We can take this outside. Okay. Now very small hole is there so that gases can travel. This is the propellant. Okay. This is one cylindrical kind of the propellant. Cylindrical propellant. Yes or no? Now, for this propellant, we have diameter, we have length also. Length of the propellant. Okay. This is what? Propellant. Yes or no? 1 meter, 32 centimeter. So this is what? 32 centimeter and this is what? 1 meter. And because this is the obviously material, so for this they have given density also how much? 1750. All right. These are the data they have given to us. Now they are asking us to calculate thrust. Okay, they have not given pressure and all, so we need to calculate thrust. And thrust formula will write here because they have given ISP. Check ISP they have given to us. So we know what is the ISP. It is thrust per unit weight flow rate of the propellant. So what will be the thrust? It is WP. W dot P means weight flow rate of the propellant into ISP, or you can write M dot P into G into ISP. So what is the M dot P? M dot P is nothing but mass of the propellant divided by burning time of the propellant, okay, into G into IS. This is nothing but thrust. Okay. Now very familiar formula. What is the formula for the mass? Density is equal to mass per unit volume. Yes or no? What is the mass? Density into volume. Density into what is the volume? Length. Okay. One length into area. Length, width into height will give volume. So because it is cylindrical body, so density is nothing but propellant rho p into length of propellant into area is a cylindrical shape. That propellant is the cylindrical shape. Check, this is the cylindrical shape. Here it is given also, I think. Check, cylindrical. Okay. So for this, what is the area? Area will be pi by 4 into diameter of the propellant. Now we'll keep all the values, so we'll get mass of the propellant, which is nothing but mp. Rho p they have given to us how much? 1750. LP they have given to us 1 meter. Pi by 4 into diameter of the propellant 32 centimeter means 0.32 meter square. Let me calculate this value. So 0.32 square into pi into 1750 divide by 4. So I'm getting here, it is 140. I'm getting 140.743 kg. All right. Now, what is the thrust we have here written? F. Check what we have written. It is MP divided by burning time, PB into G into ISP. Yes or no? So F is equal to MP. Just now we have calculated how much? It is 140.743. Burning time they have given to us how much? It is 150 seconds. Okay. If G 9.8 they have given, okay, given, they have not given, you can consider. Okay. into what is the ISP specific impulse? ISP is 190 second, right? 190 second. We'll calculate this. All value we have to calculate, multiplied by 9.8 multiplied by 190, okay, divided by 150. It is 1747.0.09. This is the point, okay, Newton. This is the value. This is the answer. All right. So hope you understood. This is very basic formula based problem only. So here we have to write 1747.094, okay, in Newton. This is the answer. So I hope this problem you understood. It's only formula based problem, right? Now, this is the next problem, 41, GATE 2015. A liquid propellant rocket has the following component. Mass of payload they have given, okay. So mass of payload, given data. Mass of payload is what denoted by ml. I will write here. Mass of fuel, it is denoted by m fuel. I will write this fuel. Mass of oxidizer, mass of structure ms, mass of guidance system gs. These are the values. So they have given all. ml 180 kg, okay. And because it is a that liquid propellant, so what is the propellant? mp is nothing but fuel plus oxidizer. Now this will be propellant. How much? 470 plus 1170. How much it is? Let me write. 470 plus 1170, because liquid propellant rocket, you know, oxidizer and fuel are separate in separate tank. So that fuel tank mass is 470 kg and oxidizer mass tank is 1170. All right. In two different tank we have. You know that liquid propellant. So that sum is nothing but 1640 kg. This is what propellant. Mass of structure, it is 150 kg, and mass of guide system 2 kg. This is what exhaust velocity, effective exhaust velocity they have given. How much? 3136 meter per second. They are asking velocity increment, means delta U. You know what is delta U? ISP G ln m naught by m. Many times I have solved this formula based problem in previous GATE exam, so you will use this. All right, we'll draw the diagram, so things will be clear more and more. All right. Effective exhaust velocity will have here. Okay. Now, this is what propellant. Okay. This is what propellant, which is nothing but MP. Sorry, wait. This is not solid propellant. This is what liquid. So I need to draw it separately. Wait. Give me time. So okay, now we have two tanks. Just say this is the fuel and this is what? Oxidizer, OX. Okay. So basically this whole part comes under propellant, MP. That you have written how much? 1640. This is the propellant. Mass of the structure, okay, that body, it is made by aluminum alloy or something, whatever the material used for that, definitely will have a structure of the rocket, and that is mass of the structure will be called ms. How much they have given? They have given 150 kg. It is very small rocket, 150 kg. All right. Then guidance system, it comes under payload, no? That guidance system here, right? It comes under payload. Here we have a payload. It may be satellite or whatever things you want to suppose launch from sea level to space, that you will keep in payload. It comes under payload and it will be in this portion actually. Okay, so in that they have given guidance system, I think, right? Mass of guidance system. So mass of guidance system. Okay. How much they have given mass of guidance system? This will be denoted by ml. Ml means payload. That comes under mass of guidance system and mass of payload. They have given separately, but like whatever the guidance system, communication system will be there, that will be the one part of that rocket, and you have to consider in this box or check, because that mass of guidance system will not, better you will not write here, or one thing I will do, so there should not be any confusion. I will say this is the plus. Okay. And now it's okay. Now it is fine. Check, because you are keeping the payload and guidance system, so payload is ml plus guidance system is mts. Now it is okay. Understood? So what is that? Guidance system is 20 and payload is 180. So it is 180 plus 20. Check. It is nothing but 200 kg. All right. Done. Now, if I say what is the initial mass now for this rocket, okay, when it is going to lift off, what is the initial mass? Initial mass means m naught. What is the m naught? So m naught, first I will write this ml, payload plus guidance system, okay, plus mp, which is mass of the propellant, plus ms. This is the total mass. Initial mass means m naught, when we are going to lift off the rocket, when we are going to launch the rocket. So this will be the total mass, m naught. Ml 180, mgs guiding system 20 plus MP, mass of the propellant oxidizer plus fuel, it is nothing but 1640. What is the MS? MS is 1 feet. So M naught, which is the initial mass, let me write as 1640 plus 150 plus 200, 180 plus 20. It is 1990 kg. This is the initial mass. Initial mass, if I say, then it means during the lift off condition, during the launch condition, what is the total mass? Because see, when you are going to, suppose payload is there, when your operation will be over, then payload, suppose it is satellite, then it will be placed in orbit. So that part you can remove at the end of the operation. But mass of the propellant, it is continuously burning. So if I say what is the final mass, MF, final mass or burnout mass. So it will be MF or MB. It is initial mass minus burnout means after complete burning of the propellant. So when propellant is what burned, so your MB or MF final or MB, it will be M naught initial mass minus propellant mass. What is the initial mass you have written? 1990 minus what is the MP? It is nothing but 1640. So this is the mass will be left part when you have uh, burned complete portion of the propellant, or after burning of the propellant, this mass will be the left part. 1990 minus that propellant mass 1640, 350. Then what is the check velocity incremental? Huh? Velocity increment, it is also called burnout velocity sometimes. It is also called sometimes change in velocity. Okay, all terms they have used in different question. Delta U, it is nothing but ISPG ln m naught by mf, or it is also ISPG, you can write V effective, okay, ln m naught by mf. How it comes? Because see, I will relate like how ISPG is what V effective. This should be very clear. This is the formula. What is the ISP? Thrust divided by mass flow rate of propellant into G. What is the thrust? It is sorry, mass flow rate of propellant into V effective. So if you relate this to, you will get what you will get. ISP G is nothing but V effective. So if I want to calculate delta U, then I will write V effective ln m naught by mf. But here delta U they have given. Okay. What we need to calculate? V effective. Delta U they have given. Check. They have given. Okay, velocity in delta U we need to calculate. Exhaust velocity they have given. Effective exhaust velocity they have given. Okay, no problem. What is that? 3136. We'll keep this. 3136 ln, what is the m naught initial mass you have calculated here? It is 1990, right? Sorry, 1 divide by 350. If you calculate this, wait, 1990 divided by 350 ln into 3136. This is nothing but 5450.23 meter per second. So what is the delta U we have calculated here? It is nothing but 5450.23 meter per second. This is the value they have asked. Answer. Okay. I hope you all understand this, because this is simple formula based problem and few concepts here. So I have elaborated that part, separate, integrated the all components like payload and structure mass, propellant mass, everything I have integrated here. So I hope you understood this. Okay. So your final answer for this is nothing but 5. Check, it is kilometer per second. So I will convert it into kilometer per second. So here this will be 5.45 5.45 kilometer per second. So there should not be mistake. Okay. So this is nothing but 5.45 kilometer per second. It is already given. So you have to write 5.45 kilometer. All right, done. So I hope you understood this solution. Keep doing hard work. Thank you. Thank you so much.